Welcome back. We're continuing talking about describing motion. Now, I've spoken to you about a new quantity now called acceleration. Okay, now we're continuing talking about it, and from there we're going to move on to what we call equations of motion. Now, say we observing an object moving in a straight line along, in the positive direction of the x-axis. Say that is the situation. But this object experiences acceleration. Now, what is acceleration? The rate of change of velocity. So it means velocity is changing over a period of time. So we having an object, it is moving in the direction positive x. Okay? So if we observe it at this point and say positive x, the direction is that way. If we observe it at that point, it is having some v or some velocity there. We're going to call it its initial velocity. It is moving in that direction, and it gets to some point there where it has got some final velocity. So we observe it at that point as well. Now, this is along the positive x-axis. Okay, this is all positive. So the change in position, in velocity here is also positive. Okay, so it's a positive acceleration. It took place over a period of time, delta t. Okay, now we can then say acceleration, which is a, can be found here. The acceleration of the object would be found by v final minus v initial divided by the change in time. Okay? Now, if we want, for example, to make v final the subject of the formula, okay? We want to try and work out, if we have this, can we find the final velocity? Definitely we can. We can multiply both sides by delta t, so we've got at this side. Okay? So in that case, we have got v final minus v initial equals a delta t. So finally, we'd have v final equals this one here. Would have gone to the side of a, so it became positive, v initial, plus this delta t here has multiplied the a there, and what do we get? We have got a delta t. Now, definitely that brings us to the very first equation of motion. Okay, so from acceleration, we can quickly get to the first equation of motion, which is the v final equals v initial plus a delta t. Now, remember, all these apply to motion in a straight line. Apply to motion where the acceleration is constant. Okay, so acceleration is a constant here. Acceleration is constant. Okay. Now, it is very important to understand that acceleration is constant here, because it helps you to understand why this equation here leads us to a straight line graph. Okay? Why? Because remember from mathematics that a straight line graph is defined by this equation here. Y equals mx plus c, where m is your gradient. Okay? Is what we call the gradient. Right. And what is c? C is your y-intercept. Now, what will be m here, the gradient? The gradient is your acceleration, something that remains constant for that particular straight line graph. So this is mx. You can see that x then becomes or is represented by delta t there. And your c, your y-axis, is the v initial. Okay, so if V here was V at the beginning, let me just use this corner here. Say this is VT. If V at the beginning was 0, you would start there and you would have a straight line. But if V at the beginning was a particular value and you have got acceleration, you might have something like that. But what you have is a straight line. Y equals mx plus c. Okay, so that's how we arrive at the first equation of motion. We'll try and show you how the others come about, but we won't use or waste time in deriving them. We will just explain how you get them independent of certain quantities. Thank you.